All right, I want to review something that wasn't an actual application, but was something that we took notes on and discussed and worked with a little bit, and that's the composition of matter. Matter falls into three basic categories. We have elements, we have compounds, and we have mixtures. The elements are kind of the building blocks. They're the basic form of matter, the simplest. So simple that you can't break them down into anything simpler. Oxygen, for example, is an element. You can't break oxygen down into anything simpler. It's already in its simplest form. They're made of a single type of atom. Compounds, chemical combination of two or more elements. Two or more elements chemically combined. Chemically, meaning they make a new substance, something with unique properties. They can be broken back down into elements through chemical change. And they have what we call a fixed ratio. This is what that chemical formula that we've been working with is all about. That chemical formula tells us what that fixed ratio is. Table salt, sodium chloride, is a compound. It is a chemical combination of sodium and chlorine. It is nothing like sodium and chlorine. It's a unique substance with its own properties. Sodium's a metal. It's silver. It's kind of soft. You can cut it with a butter knife. Has a very low melting point for a metal, about 210 degrees, something like that. One of its big properties is it's explosive in water. Chlorine is a gas at room temperature. It's green in color, very, very low melting and boiling point. It's a gas at room temperature, and it's toxic. You can combine them together to make the sodium chloride. It looks nothing like sodium or chlorine. It's a very hard, white, crystalline solid. It has a very high melting and boiling point. It doesn't blow up when you put it in water, and it's not toxic. It's going to kill you. So again, when it's combined together chemically, it's totally different. It's totally new. It can be broken back down into elements again. Sodium and chlorine can be separated out of this table salt, the sodium chloride. It would require a chemical reaction to do that. And it's got a fixed ratio. It's always 1 sodium to 1 chlorine, thus the formula NaCl. Mixtures are 2 or more of these pure substances. These elements are compounds. That are combined physically. They're combined physically, not chemically. They can be broken down by simple physical means. They can be separated. They can be combined in any ratio. Salt water is a mixture. It's a physical combination. When the salt and the water combine, they don't make anything new. They're still just salt and water. They can be separated by simple physical means. You can simply boil the water off. Water has a much lower melting point, boiling point than what salt does. So by heating it up, you can get the water to boil out and leave the salt behind. It's a process called distillation. And they can be mixed in any ratio. You can have a small amount of salt in your water. You can have a large amount of salt in your water. They're not stuck in a ratio like the compounds are. That's why there's no chemical formula for it. Visually speaking, if we were looking into a container that had an element in it, we'd see atoms, and all the atoms would be exactly the same. They could be bonded together to make molecules like they would be in the case of an oxygen molecule. But again, you'd only see one kind of atom there. In a compound, you're going to have molecules. You're going to see two kinds of atoms there, but you're only going to see one type of molecule. I guess I forgot to put that up there. So we can have two different atoms in there, the white ones and the black ones. But those molecules have been combined together in a single way. All the molecules are the same. That is a compound. In a mixture, we're going to see a variety of things. And it could be elements, it could be compounds, but we're going to see a combination of stuff. It's no longer uniform. I have these elements in here, I have these compounds, and I can distinctly see I have two different things in my mixture. I need to talk about physical and chemical properties too. That's something that we covered this quarter. It's not really application so much as it is just stuff you got to know. Physical means nothing new. Chemical means something new. And the way they apply here is that when you're talking about properties, these are observations. A physical property is one you can observe without changing the composition, without making anything new. A property you can observe without making something new. This includes stuff like color, shape, size, texture, anything we observe with our senses, length, mass, volume, or anything we measure with a tool. A physical property tends to be things we observe with our senses or things that we measure with a tool. And again, you can measure the length of something and you're not going to make anything new out of it. I could say the paper is 11 inches long, but it's still going to be paper. This is the physical part of it. You can observe it without making something new. For a chemical property, to observe it, you have to make something new. To observe it, you have to make something new. And chemical means something new. This includes stuff like flammability, corrosiveness, etc. Things that describe the way things react. To observe flammability, you would actually have to burn something, and when you burn something, you'd make something new, thus chemical. To observe corrosiveness, you'd have to have something corrode away, and when it corrodes, it would make something new, like the terminals of a battery. If you ever looked at a car battery and you saw the green stuff on it, that's what the metal turns into when it gets corroded. It's something new. That's why it's a chemical property. Now, physical properties are very useful for us because physical properties allow us to separate mixtures. We can separate mixtures with physical properties. Distillation, that's separating by boiling point. Like separating salt and water. The salt has a much, much higher boiling point and melting point, for that matter, than water does. So you heat the water up, the water boils, changes to a gas, it escapes, and it leaves your salt behind. That's distillation. Boiling point is a physical property. You can observe it without making something new. When you boil the water, it starts off as water, and the steam that comes out is water, so it doesn't make anything new. It's just a physical property. Filtration is separating by size. It's great for separating solids and liquids like sand and water. The filter has holes in it, and because water is a liquid, the particles move through very easily. The sand is a solid and it's bigger, and as such it gets trapped behind. So it separates the water and the sand by size. There's one we didn't get a chance to do called chromatography. And this separates by the weight of a dissolved substance. Basically, you take a container that has a solvent in it, and you stick a piece of chromatography paper in it that has a dot of, say, a pigment on it, like ink. And what will happen is as the solvent moves up the paper, as it's absorbed by the paper, it'll start separating out the different pigments. And you'll see like the black ink's made out of yellow. You might see the yellow down here, and green, and blue. You see all the different pigments that go into making up that black ink. And they're getting separated out by their weight. Weight is a physical property, so chromatography is separating by weight. Physical properties are a great way to separate mixtures. Another thing they're good for is identification. This is what density is great for. Mass per unit volume. Most substances have a unique density. So if you can measure the density of an unknown, you can compare it against different known substances to figure out what it's made of. It's like the one question in our study guide with whether the penny was made of copper or zinc. If you measure the density of the penny, you can compare it to the densities of copper and zinc and see which one it matches. If it matches the copper density, then you know the penny was made out of copper. If it matches the zinc density, then you know the density is zincs. The penny's made out of zinc. So it's great for identifying substances too.